Thank you. Thank you so much. So first of all, it's my enormous honor to be able to speak to this community, which thanks to Stephanie that I'm reaching. I mean, I'm not going to go, if you want to know more about me, I have a long life in the business of Earth observation. Just Gilberto.org will suffice. So Stephanie asked me to talk about big Earth observation data analysis. So I'm going to assume no previous knowledge, just in case that I know many of you know things about it, but just in case, let's start from scratch. So the basic point here is the open data policy for Earth observation satellite data. And this has been a major change in my lifetime. I hope thanks for having a very, very nice gender balance here, gender imbalance in the good side. But I'm old enough to remember a time when one Landsat image cost $500, $1,000, that was it. And now you can get all Landsat archive open. So you have an open data policy, which is quite recent, not within even a decade. And now the question has become to everyone, what can we do with such data? And again, the prevailing paradigm that has, let's say, settled in the community in Earth observation is following the new digital economy, which is basically having a number of big data services by companies or by public services, mostly companies, in a way to access this service at low cost and hopefully a massive use. Obviously, this is the case for maps applications, which are now, people don't even remember the time that we had to open physically a physical map going in Europe and going to the wrong places, but that's a long story. So where are we? We are in a certain mix of things. We are in the, let's say, big satellite data is a reality. Services that host data are becoming available, but they're not standard. And what I'm trying to do is kind of clarify this. And lots of people are trying to do whatever. We just talked about ChatGPT and machine learning or applications for mobile data set. And what's the deal here and why is it tough? The first point I used to say, it's the elephant in the room. And this is obviously for those of you, the African savanna, you might wonder yourself, well, there's a savanna in Brazil. Why don't we have a megafauna in Brazil? And it's a good question. Yes, we had the megafauna in Brazil. It was wiped out 30,000 years ago. And the megafauna in Africa. And again, as you know, the fauna itself modifies the ecosystem. So there's certain peculiarities in the African savanna that you don't have in Brazilian savannas. When we call them all savannas, we actually undermine the ecological knowledge. So my point is, local knowledge will be essential. And it's not going away anytime soon. And one of the reasons is that we are observing the Earth and giving names. A lot of the time, we're giving names to things. And these names are polysemic. We give the same name to things which are completely different. Forest is a typical example. Savanna is another one. And lots in agriculture is third. You can go forever. And in our work in either conservation biology or land use change, which is my area, starts giving names. And these names don't really have a sense of generality. So what is the change? The change now is that for those in the know, and I would imagine anyone coming new to Earth observation, would now start learning Earth observation by using a tool like Google Earth Engine. So what is Google Earth Engine? Google Earth Engine is a tool which is lots of data, has a very simple, and I'm going to argue it's really simple to learn and it's worth the time, an application programming interface. and a lot of things you can do with that application programming interface. You can, in this case, what's there? Not everything is there. The typical things which are there are the open archives from satellite agencies. So that's Sentinel and Landsat, Sentinel from European Commission and Landsat from United States, and there's MODIS from NASA. There's some vector data. You will not find a lot of data. There's some links to GBIF, but that's another story. Terrain and land cover and some weather data. Lots and lots and lots and lots of data. Okay. What can you do with this data? Whatever Google lets you do. And that's a little bit of the snack. In other words, the application programming interface of Google can allow you to do a lot of things, like selecting a set of images that match a certain area or time or sensor. You can apply something, but you cannot do everything, because it basically is limited to the functions Google gives you. I'm going to argue that if anyone coming new to Earth observation will do himself or herself or whoever self a favor by learning to use Google, but not stopping there. There's a lot that can be done, a lot of data that can be explored. This is no prizes for guessing. This is urbanization in China. No prizes for guessing. This is deforestation in Brazil. And this is basically time-lapse of Landsat images. And this is some, in Peruvian Amazonia, some of the evolution, natural meanders of the rivers. And you can do a lot. A lot of people are exploring data. For example, this is a paper that came early on, mapping tree height distributions in sub-Saharan Africa using Landsat and 8. Basically, you can sense, in this case, it's an application that uses one image per year, and then it does the distribution based on years and so on. Anything to do with time, that time is a problem, can fit well within this model. And this is also someone that actually went as far as the New York Times, the global surface water map, which is actually, if you work in Earth observation and you want a surface water mask, this is the one to go, the Packer one. So very interesting, nice to do. Doesn't solve all the problems though, because a lot of things that we do on land change and conservation, and it has to do with the temporal evolution of your data. You have a series of satellite images. Each pixel of that image is associated with one time series. And in Google, it's very hard to do actual time series analysis. You actually analyze images one by one, or typically, for example, you get one best image per year. And at that moment, in environments which have a marked dry and wet season, anything tropical, for example, you get a mess because you mix the seasons. And any kind of seasonality analysis is sort of lost. And for example, it becomes very difficult, just to give you one example close to my heart, is to distinguish between a natural savanna and a pasture. From a biodiversity point of view, there's huge distinction. This is native species versus basically invasive species imported from Africa, Brachiaria. But from the satellite point of view, if you don't have, and there's significant differences between those, not in a single image, but in a time series, because of the differences, the adaptation of the native vegetation and the low adaptation of the grass between the dry and wet season. The result of this is there's a product that some of you may be tempted to use, for example, to do biodiversity analysis at a large scale. For example, this is the ESA world cover, done with Sentinel data. And this is a place on the Brazilian Cerrado, and the yellow, no prizes forget, this yellow is grasslands. And the second one is the same area we done for the entire Cerrado in Brazil with my team, where we separate the man-made pasture, the grasses, the not native grasses, with the native savanna, and then look at the difference. So what the blue, greenish, light greenish color, this is actually the natural vegetation. The sort of yellowish color is the pasture, and it's completely different ecosystem. The conclusions you're going to take are completely different. For this reason, for example, I'm currently working with a planetary computer, which is Microsoft. The planetary computer, what does? It's much, in a certain sense, it's the sky is the limit, but you're the limit in planetary computer. You get the machine, for example, an R machine or Python machine with 8 cores for free. You register, you get a machine. You get similar sort of data that you're going to use in Google. And you can select images. I was looking for the mining, illegal mining, which is causing a major disruption and terrible humanitarian disaster in Brazil, if you heard the news, and with the Yanomami tribe. But you're on your own. Okay, in other words, if you are an R user, and we've developed packages, so if you are comfortable with writing your own code and using other code in R, then you're in safe hands using the Microsoft Planetary Computing. Because here, for example, this is our software, which emulates Google Earth Engine, but does more than Google Earth Engine. The first speaker talked about attention, for example. So this, for example, is a classification, just a small example of classification of deforestation using something in the jargon called lightweight temporal attention model. You don't have that in Google, and it's better than the random forest model that's in Google. So we actually are working on classification of deforestation and land use in Amazonia using this kind of model. That can be done with Microsoft Planetary Computer. That cannot be done with Google. So this is like, in a nutshell, the difference. If you are starting from scratch, and again, you have to remember the simple rule here. And I'm going just to put this slide as my final slide. So actually, it took 10 minutes, Stephanie, better than you asked. No, I could talk for 2 hours, but I think on the benefit of the time, it's easier to pass a clean message. You have to understand that you, an ecologist, a biodiversity conservation person, need to really believe in yourself. The use of ChatGPT, the problem is language is its own meta language. In other words, natural language is its own, you describe natural language in natural language. Whereas when you are in Earth observation, you describe the world in words, but the world that you measure in satellite data is not words. There's a huge difference between large language models for language and large language models for remote sensing. And I'm going to argue the world is, in language models, you have a lot of things that are being written. My daughter has a PhD in philosophy, and she asked ChatGPT a question about Plato. And the response was almost perfect. Why? Because we have 3,000 years of people writing about Plato. And most of the writing about Plato that goes into Wikipedia or in ChatGPT is good writing. So what comes out is good. Now, of course, you would not expect the same kind of thing about Donald Trump or Jair Bolsonaro, for that matter. So words make a difference. You, an ecologist, if you want to start the game, the first thing, if you know nothing about anything, Earth observation, learn Google Earth Engine. Start with the basics. Then when you have mastered it, you will find out that it cannot do everything you need. Then you move to Microsoft and hopefully can use some of the packages that are available. If you are an R person, you're going to be happy because there are lots of things in R, including our package and many others. And on the slides, there are pointers to it. So, Stephanie, thanks again for having me. It was wonderful. And I said, old people are disciplined, you know?
You are. You should teach everyone else. Look, I'm glad you tolerated our chaos. That was wonderful. Like, that so exceeded my expectation. What if we gave you 2 hours? What would you talk about?
Well, I would discuss essentially some of the issues of what happens in the concepts that we design an ecosystem. There's a very nice paper by Robin Shadson, which is called "When is a Forest a Forest?" Beautiful paper. I think it was either ecological modeling or some. It's a beautiful. Read it.
Okay.
And it's a very nice nice paper, which because it essentially tells you that some of our concepts that we assign to ecosystems are derived from observations, go there, see, or look at remote sensing data, but are implicitly derived from the temporal behavior in either on a short scale, 1 year, or if you're into the game, into a longer time scale, centuries or thousands of years. A lot of what we tag the world is assigned to temporal knowledge. And that gets lost if you just see one remote sensing image or if you go to the field only once.
Okay. You might want to jump into the chat because there are a lot of comments and applause and just, I think we've got a little fan club that's formed. And
oh, come on.
I think that was wonderful. And we may have you back for 2 hours. I would happily listen to you explain complicated things very simply to me forever. So thank you so much for joining, and thank you to all of our speakers.